Hi there, in this video I'm going to do a past exam question on trigonometry. So let's go to this question. So the question reads, question 1 part A, by writing sine 3 theta as sine 2 theta plus theta, show that sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. So let's see how this is done. Let's get back to the paper and pen. Now, in order to do this, I'm going to use the compound angle formula for sine A plus B. So here is the compound angle formula for sine A plus B. Now, if you're not aware of the compound angle formulae, I've created a video explaining the formulae and how it's applied in a video that I did earlier, and I'll provide a link to these videos in the description below. However, let's move on. Sine A plus B has the form sine A cos B plus cos A sine B. So let's figure out what A and B are with regard to this formula. Now, A by comparison is 2 theta. So let me make a note. A is 2 theta. And B by comparison is theta. So B being theta. So this is A and B for the formula. So if I replace A and B in the formula, we're therefore going to get that sine A, which is 2 theta, plus B, which is theta, that is equal to sine A in this case is 2 theta, cos of B being theta, plus cos A, which is 2 theta, sine B being theta. So that is what we have at the moment upon replacement of A and B in the compound angle formulas for sine A plus B. Now, if we go back to the question, in this case, the form that we want it in doesn't involve cos terms. So if we go back to the paper and pen, at the moment we have cos terms appearing in our expression so far. So somehow we need to get rid of these cos terms. Also, if you go back to the question in itself, the form that we want it in doesn't have sine 2 thetas or cos 2 thetas appearing. In particular, it's in the form of sine thetas only. Okay? So in other words, we need to rewrite what we have at the moment in terms of sine thetas only. So if we go back to the paper and pen, in order to do that, there are identities for sine 2 theta and cos 2 theta. So let me include these identities as a side note. Now, sine 2 theta, or the double angle for sine, is 2 sine theta cos theta. So that's the double angle for sine. We can replace sine 2 theta by this form. Okay? And in regards to cos 2 theta, we can write it in terms of sine theta. We can write it as 1 minus 2 sine squared theta. So that's the double angle formula for cos. Now, if you're unaware of the double angle formulae, I have created a video explaining the double angle formulae, and I'll provide a link to this video in the description below. Let's move on from there though. Let's therefore replace the sine 2 theta and the cos 2 theta by the appropriate forms, giving us sine 2 theta plus theta on the left hand side. That is equal to sine 2 theta. Let's replace by 2 sine theta cos theta multiplied by the cos theta term here, plus cos 2 theta. Let's replace that by 1 minus 2 sine squared theta. Not forgetting the sine theta here. Now, if we go the extra stage, let's get rid of the brackets. So 2 sine theta cos theta times cos theta is 2 sine theta cos times cos is cos squared theta, and 1 times sine theta is sine theta, and minus 2 sine squared theta times sine theta is minus 2 sine cubed theta. So we have this at the moment. Now again, if we go back to the question, the form that we want it in is in terms of sine thetas only. So if we go back to the paper and pen, I have it, I'm nearly there, however I have a cos squared theta term, and we can use an identity to rewrite the cos squared theta in terms of a sine theta term. Now let me do this, let's do this as a side note. Now remember the fundamental Pythagorean identity. So remember the identity that cos squared theta plus sine squared theta is equal to 1. And if I rearrange for cos squared theta will therefore be 1 minus sine squared theta. So what I'm going to do now is I'm going to replace the cos squared theta by 1 minus sine squared theta. So let's do that. So if I do the replacement, I'll have 2 sine theta, cos squared theta, that is 1 minus, so 1 minus sine squared theta, plus the sine theta, so plus the sine theta, minus the 2 sine cubed theta. So we're nearly there. Now if we get rid of the brackets, we're going to have 2 sine theta times 1 is 2 sine theta. 2 sine theta times minus sine squared theta is minus 2 sine cubed theta. So sine theta times the sine squared theta is a sine cubed theta, plus the sine theta minus the 2 sine cubed theta. And if we add the like terms, 2 sine theta plus sine theta is 3 sine theta, and minus 2 sine cubed theta minus 2 sine cubed theta is minus 4 sine cubed theta as required. So this is what they want it in. This should be the form for sine 3 theta. Let's have a look at part B of question number 1. Given that sine theta is root 3 over 4, find the exact value of sine 3 theta. So most commonly, when it comes to exam questions, the parts are linked to one another. So spot if there's a pattern, or spot if there's something that you can use from a previous part. So in this very question, I can use the previous part to help me with part B. So let's go back to the paper and pen. So we have the value of sine theta, which is root 3 over 4. So from part A, we've seen that sine 3 theta is 3 sine theta minus 4 sine cubed theta. Now we have this value of sine theta, which is root 3 over 4. So let's simply replace that value in this form to give us 3 sine theta, which is root 3 over 4, minus the 4, and sine cubed is the same as sine theta to the power of 3. So I can replace it as a result to give me root 3 over 4. That is the value of sine theta to the power of 3. So remember, bearing in mind that sine cubed theta, that is the same as sine theta to the power of 3. So bear that in mind. Now, that is what we have for sine 3 theta at the moment. And if we go one extra stage, let's simplify. So 3 times root 3 over 4, that is 3 root 3 over 4 minus 4 multiplied by root 3 over 4 cubed, that is 3 root 3 over 16 when multiplied. And if we take a common denominator of 16, we're going to have 9 root 3 on top. So that should be the solution to part B. So that's the solution to part B, and that is the solution to question 1 as a whole. So I hope you found this video helpful. I hope you enjoyed this video. If you did enjoy the video, a like rating is very much appreciated. Do plenty of practice related problems, and I hope to see you again. Thank you.